I'm Peter Styring and I'm Professor of Chemical Engineering and Chemistry at the University of Sheffield. Now, when this session was first set up, I had every intention of being here, but due to a diary clash, I'm actually on a plane on my way to Germany at the present time. However, this is meant to be a session on being creative, so here I am. I've made a short video to show some of the thought processes that can be used when being creative in research in chemical engineering and sciences. As chemical engineers, we're looking to make things that make a profit. Now that may be on a big scale, the conventional scale that you associate with chemical engineering, or that might be on a small scale. And in fact, we take nature as a lead there. Most of nature's materials are made on a very small scale, in fact on the microscopic scale. We've developed a series of microreactors. Now, the advantage of microreactors is that you do things on a small scale, but then you go to a larger scale by replication, in the same way that a body has a cell that makes things, but it has many cells that make a large number of things. One of the things that chemical engineers do is convert energy from one form to another. Burning a flame is one good example of that. While we generate heat, we also generate carbon dioxide because we're burning fossil fuels. That carbon dioxide is emitted to the atmosphere together with water vapour, and the carbon dioxide contributes towards global warming. The thing about carbon dioxide is you can't see it, but it's always present during a combustion process. Another area of my research is sports engineering, in particular making skis go faster. Usually we wax a ski using a hot waxing process. It's very energy intensive and also has to be done in a workshop. If you look again to nature, think of the slug. The slug moves by secreting a layer of slime underneath its body. This acts as a lubricant and allows the slug to move across the ground. Now we can apply the same sort of methodology to the skis by applying a continuous layer of lubricant underneath the ski, then the ski will move faster. Now, there is a link between snow sports engineering and CO2 emissions. While most ski resorts are in quite remote locations, they do suffer from climate change because of industrial process occurring close by in industrialised areas of the region. A good example of how climate change is affecting ski resorts can be found on the Grand Motte Glacier in Tignes. The glacier is receding at an alarming rate, and therefore the skiing is having to go higher and higher. I was fortunate last year to talk to Eric Berthon, the former World Champion Moguls skier and former French coach, and he gave me some of his views on whether or not climate change is real.
Because I started skiing here a long time ago, maybe in 83, 84, and for example the cliff just behind us here, this was only ice, with a big wall of ice cover of snow and a nice corniche on the top. And I remember when I was younger it was possible to jump this corniche on the top and to land on nice snow, and now it's only rocks, and it's just cover of snow now for in the winter and Christmas.
In the past, skiing has taken place at a much lower altitude. As you can see from the video, the snow line is gradually getting higher and higher. There will come a time when it becomes impractical to ski because the glacier has receded to such a high degree.
Progressively we lose the snow on the bottom, and now we're here on the top of the glacier, and we lose the snow here, and we know now that it's not possible to go higher.
Climate change, but it takes someone who lives in the mountains and sees the effects day on day to show that it is in fact real.
It's beautiful, but when you spend a lot of time here every year, you really understand what's happened with global warming.
It's the responsibility of scientists and engineers to help minimise the effects of climate change. One of the ways we're trying to achieve this at Sheffield is to look at taking the carbon dioxide emitted from energy from waste plants and converting it back into useful chemicals such as fuels. We're also looking at how we can preserve snow sports viably in the future. That might mean moving to indoor arenas with very efficient energy exchange systems, or it may mean developing new artificial snow that we can add to the mountain environment. So generally, scientists and engineers take their inspiration from a wide range of sources. It may be art, it may be sport. Whatever it is, there's a lot of information out there that the scientists can use in their research. Indeed, you find that many scientists and engineers have hobbies in the arts. They use it as a form of relaxation as well as inspiration. And I'm sure that's the case with many social scientists and artists. I know several that take inspiration from science, but the question is, do they use it as a relaxation form as well? Again, I'm sorry I can't be here with you tonight, but I hope you've enjoyed the event, and indeed you'll continue to enjoy conversations and discussions on the subject of the science and social science interface. At this point, I would ask you if you've got any questions, but obviously that's going to be impractical. So what I've done is I've left my email address on the end of this video. If anyone wants to contact me, then please feel free to do so. Again, good night and thank you.